All right, let's continue by talking about inverse functions. So when you think about inverse functions, what you want to think about are the undoers. So an inverse function is an undoer. For instance, addition and subtraction are inverse functions. Multiplication and division are inverse functions. Squares and square roots are inverse functions. Basically, the opposite of multiplying by 3 is dividing by 3. The opposite of adding 4 is subtracting 4. When you think about inverse functions, you're thinking about how would I solve for x, basically. So we're going to start not by finding inverses, but by if we have two functions, can we check whether they're inverses? Well, when you think about inverses, because they're undoers, if you plug 2 into one function and then do the opposite function on it, you should get a 2 back out. So two functions are inverses. This is the notation we use for inverse, this f to the -1. If f inverse composed with f gives me x, and f composed with f inverse gives me x. Notice that I'm going to do it in both directions, so it has to work in both directions. And when I do that function composition with the two functions, we call them inverses. So given two functions, we can test whether they're inverses by finding f of g of x and g of f of x. If they turn out to just be x, great, inverses. If one of them is not x, then they're not going to be inverses. So here are two functions. F of x is 3x plus 6, and g of x is 1/3 x minus 2. And I want to verify that they're inverses. So basically, I want to compute f composed with g of x, and I want to compute g composed with f of x and see what I get. If I get x in both of these cases, then they're inverses, and I know that we're good. So to find f composed with g of x, I'm going to take g, which was 1/3 x minus 2. I'm going to plug it in f right there where I see the variable. So 3 times 1/3 x minus 2 plus 6. So I begin by distributing that 3. 3 times 1/3 x makes x. 3 times -2 makes -6. I still have this plus 6 at the end. I have minus 6 plus 6. They cancel, so I'm left with x. That's good news. Now I'm going to do the other correction, g of f of x. So I'm going to take the f of x, and I'm going to plug it into g. So g of 3x plus 6. So I'm going to take that 3x plus 6, plug it in there for x. So 1/3 times 3x plus 6 minus 2. Distribute my 1/3. 1/3 times 3x makes x. 1/3 times 6 makes 2. I still have that minus 2 at the end. Minus 2 plus 2 cancels out, so I'm left with x. So because when I computed f of g of x and g of f of x, I got x in both cases, then I say yes, they are inverses. If you're thinking about this in your head, you're thinking about this says multiply by 3 and add 6. The opposite of that would be to subtract 6 and divide by 3. So to subtract 6 and divide by 3 is equivalent to this 1/3 x minus 2.